When pilots talk about their favorite aircraft, one plane consistently sparks particular enthusiasm. They call it the hot rod of commercial aviation, describing it with an almost reverent affection that's rare in the pragmatic world of airline operations. That aircraft is the Boeing 757, and even though the last one rolled off the production line nearly 2 decades ago, its absence is still felt acutely across the aviation industry today. To understand why the 757 remains so beloved, we need to go back to its origins. In the late 1970s, airlines faced a peculiar problem. The energy crisis had made fuel efficiency paramount, but passenger demand was growing in unpredictable ways. Routes that had once been marginal were becoming viable, but not viable enough to justify wide-body aircraft. Airlines needed something that could replace aging 727s and early 737s, something more efficient, but they also needed versatility that existing aircraft simply couldn't provide. Boeing's answer to this challenge would become one of the most remarkable commercial aircraft ever built. The 757 entered service in 1983, and from the very beginning, it was clear this wasn't just another narrow-body airliner. Let's start with what made this aircraft so technically exceptional, beginning with the power plants that gave the 757 its legendary performance. The 757 was offered with 2 engine options, the Rolls-Royce RB211 and the Pratt & Whitney PW2000 series. These weren't just efficient engines, they were extraordinarily powerful for an aircraft of this size. The RB211 535E4, for instance, could produce up to 43,500 pounds of thrust per engine. To put that in perspective, that's roughly the same thrust as the engines on the much larger Boeing 767, which shares the same engine family. This meant the 757 had a thrust-to-weight ratio that was exceptional for a commercial airliner. It was, quite literally, overpowered in the best possible way. This surplus of power translated into performance characteristics that pilots absolutely loved. The 757 could climb like a fighter jet, relatively speaking. Pilots would talk about the 757's smile, that moment after rotation when the aircraft would leap off the runway with authority that felt more like a business jet than a commercial airliner carrying up to 239 passengers. At lighter weights, the climb performance was spectacular. There are countless stories of air traffic controllers being caught off guard by how quickly a 757 could reach its assigned altitude, often requesting confirmation that the aircraft had actually leveled off where instructed. But raw power was only part of the equation. What truly set the 757 apart was its wing design, and this is where Boeing's engineering brilliance really shines through. The 757's wing was a masterpiece of aerodynamic efficiency, featuring a supercritical airfoil design that was advanced for its time. The wingspan measured 124 feet 10 inches, with a wing area of 1,994 square feet, optimized for both high-speed cruise and low-speed handling. The wing incorporated sophisticated high-lift devices that gave the 757 remarkable short-field performance. The leading edge featured variable camber Kruger flaps on the inboard sections and slats on the outboard sections. The trailing edge had double-slotted flaps that could extend to 30 degrees for takeoff and up to 40 degrees for landing. When fully deployed, these systems transformed the wing's characteristics dramatically, allowing the 757 to operate from airports where other aircraft of similar capacity simply couldn't go. This wing design gave the 757 an unusual combination of capabilities. In cruise, at typical operating altitudes between 35,000 and 42,000 feet, the 757 was fast. Its maximum operating speed was Mach 0.86, and it could cruise efficiently at Mach 0.80. This was a narrow-body aircraft that could match or exceed the cruise speeds of many wide bodies while carrying a full passenger load. But where the wing really proved its worth was at the other end of the performance envelope. the 757 could approach and land at speeds that were surprisingly low for an aircraft of its size and weight. This meant it could use shorter runways and operate into airports with challenging approach profiles. Mountain airports, airports with noise restrictions requiring steep approaches, and airports with short runways all became accessible to an aircraft that could carry a substantial payload over considerable distances. Let's talk about those distances, because this is where the 757 really distinguished itself. The 757-200, the most common variant, had a maximum range of approximately 3,900 nautical miles. The extended range 757-200ER could fly up to 4,500 nautical miles. These weren't just numbers on a specification sheet, they represented a fundamental shift in what airlines could do with a narrow-body aircraft. Suddenly, transatlantic routes that had been the exclusive domain of wide-body aircraft became viable for a single-aisle plane. This is where we need to discuss ETOPS, or Extended Range Twin Engine Operational Performance Standards. In the early days of jet aviation, regulations required twin-engine aircraft to remain within a certain flying time of an alternate airport in case of engine failure. This severely restricted where twin-engine aircraft could fly, especially over oceans. The 757, along with the 767, became pioneers in pushing these boundaries. The 757 was eventually certified for ETOPS 180, meaning it could fly routes that were up to 180 minutes flying time from an alternate airport on one engine. This certification was crucial because it opened up transatlantic routes to the 757. Airlines could now fly from the east coast of the United States to secondary European cities, or from the west coast to Hawaii, with an aircraft that was sized perfectly for these markets. These were routes that didn't have enough demand to fill a 747 or even a 767 profitably, but had too much demand for a smaller aircraft. The 757 hit the sweet spot perfectly. This capability created an entirely new category of routes that the industry calls long, thin routes. These are routes with long distances but relatively modest passenger demand. Before the 757, airlines had to choose between using a larger aircraft that flew half empty, losing money on every flight, or not serving the route at all. The 757 made these routes not just possible but profitable. It could carry enough passengers to make the economics work while having the range to cover the distance. Airlines began opening routes that had never been economically viable before. Regional cities in the United States gained direct service to European destinations. Caribbean and Latin American routes that had required connections suddenly had direct flights. The 757 was connecting city pairs that had never been connected before with jet service. It was democratizing international travel in a way that no previous aircraft had managed. The performance benefits weren't just about range. The 757's power and wing design made it exceptionally capable at hot and high airports, those challenging airfields at high elevations or in hot climates where the thin air dramatically reduces aircraft performance. Airports like Mexico City, Denver, and Johannesburg, which pose significant challenges for many aircraft, were well within the 757's comfort zone. The aircraft could operate with full passenger loads and reasonable fuel reserves from runways where other narrow bodies would need to limit passengers or cargo to get airborne safely. Pilots loved the 757 for another reason. It handled beautifully. The flight control systems, while conventional for the era, were well harmonized and responsive. The aircraft felt solid and predictable throughout its flight envelope. In turbulence, it rode smoothly. In crosswinds, it could be landed with confidence. It was, by all accounts, simply a joy to fly. The 757 also introduced technological advances that were significant for its time. It was among the first commercial aircraft to feature a two-crew glass cockpit, eliminating the need for a flight engineer. The avionics suite included advanced navigation systems and flight management computers that reduced pilot workload and improved efficiency, the cockpit design was harmonized with the 767, allowing pilots to be type-rated on both aircraft simultaneously, which gave airlines valuable operational flexibility. For airlines, the 757 represented operational efficiency in its purest form. The aircraft's reliability was legendary. Dispatch reliability rates, the percentage of flights that depart on time without maintenance delays, regularly exceeded 99%. The 757's fuel efficiency, combined with its payload range capability, meant that airlines could operate routes profitably that would have been marginal with other aircraft. Whether flying a 500-mile domestic segment or a 3,500-mile transatlantic route, the 757 could do the job efficiently. Different airlines exploited the 757's capabilities in different ways, which speaks to its versatility. Some carriers used it primarily as a domestic workhorse, taking advantage of its short-field performance and powerful engines to operate efficiently on dense, high-frequency routes. Airlines like Delta and American built substantial fleets for exactly this purpose. Other carriers saw the 757 as their gateway to international expansion. Airlines like Icelandair and Condor built business models around using the 757 to connect secondary cities that couldn't support larger aircraft. These airlines could offer direct service from smaller European cities to North America, avoiding the need for passengers to connect through major hubs. The cargo variant also proved incredibly popular, particularly with express freight operators like FedEx and UPS. The aircraft's combination of range, capacity, and performance made it ideal for time-sensitive cargo operations. Even today, long after production ended, converted 757 freighters remain in high demand. FedEx alone operates more than 70 757 freighters with no signs of retiring them. So with all these advantages, why did production end? Boeing delivered the last 757 in 2004, and that decision continues to be debated in aviation circles. Boeing's reasoning was straightforward. They believed the market was moving towards smaller wide-bodies and larger narrow-bodies. The 787 Dreamliner would handle the small wide-body market, while the 737 family would be stretched to cover the 757's capacity range. Airlines, Boeing believed, would accept slightly compromised performance in exchange for commonality with existing 737 fleets. The problem is that this analysis turned out to be incomplete. The 737, even in its latest iterations, simply cannot replicate what the 757 could do. The 737 MAX series has more range than previous 737 variants, but it lacks the 757's payload capability on long, thin routes. More critically, it lacks the 757's hot and high performance and short field capability. A 737 cannot operate with full payload from the same short runways where a 757 performed comfortably. It cannot climb as steeply or as quickly. The 787, meanwhile, is simply too large for many of the routes the 757 served. Using a 787 on routes that only need 200 seats is economically unviable for most airlines. The aircraft costs more to acquire, more to operate per flight, and requires more passengers to break even. For those perfect long, thin routes that the 757 dominated, the 787 is overkill. This has created what industry analysts call the middle-of-the-market gap. There's a need for an aircraft that can carry between 200 and 270 passengers over ranges up to 5,000 nautical miles. With excellent short-field performance and operational flexibility, the 757 filled this need perfectly. Today, no aircraft in production truly does. The 757 fleet is aging, but airlines are holding on to these aircraft far longer than typical for commercial jets. The average 757 in service today is over 25 years old. In normal circumstances, aircraft of this age would be well into retirement, but airlines continue to invest in maintenance, refurbishments, and even major modifications to keep their 757s flying. Delta Airlines has retrofitted many of their 757s with new interiors and systems upgrades. United Airlines has done the same. These aren't trivial investments. They're multi-million-dollar commitments per aircraft made because the alternative means accepting compromises they're not willing to make. The used 757 market reflects this demand. While most commercial aircraft rapidly depreciate, well-maintained 757s command premium prices. Airlines actively seek them on the used market. Some aircraft have changed hands multiple times, continuing to fly revenue service for airline after airline. This simply doesn't happen with aircraft that have adequate replacements available. Passengers have lost something as well. The 757's capabilities meant more direct flights and better service to secondary cities. As these aircraft retire without replacement, some of those direct flights are disappearing. Passengers from smaller cities are finding themselves connecting through hubs again for flights that used to be direct. There's been periodic speculation about Boeing developing a 757 replacement, but nothing has been committed to production. Airbus's A321XLR variant extends range considerably, but even Airbus acknowledges that their aircraft doesn't quite match the 757's performance envelope, particularly in short field and hot and high operations. What made the 757 truly special wasn't any single characteristic. What made it irreplaceable was having all of these characteristics in a single airframe at a size and operating cost that made sense for a wide range of routes. It was the combination that created something unique. The 757 story is ultimately about the unpredictability of aircraft design. Boeing couldn't have fully anticipated all the ways airlines would utilize the 757 when they designed it. What they created was an aircraft that opened up entirely new possibilities in airline network planning. The engineers who created the 757 achieved something remarkable. They designed an aircraft so well suited to its missions that, decades later, with all the advances in technology, the industry hasn't produced a better solution. The 757 set a standard that remains unmatched. The Boeing 757 stands as a reminder that sometimes, in the pursuit of efficiency and commonality, the industry can lose sight of the value of pure capability. The 757 had capability in abundance, and that capability created value in ways that spreadsheet analysis sometimes fails to capture. Until someone builds another aircraft that can do what the 757 could do, the industry will continue to feel its absence. That's the mark of a truly special aircraft, and that's why the 757's legacy endures.